exactly how we can find values for pressure, volume, temperature, or the number of particles. We've looked at the relationships for the past couple of weeks. We know that if the volume increases, the pressure will decrease. We know that if the temperature increases, the pressure increases. If the number of particles increases, pressure increases. So we know these different relationships. So if we're given certain values, how does it change other values? So we want to look at these and be able to calculate. So one of the relationships that we didn't talk about was temperature and volume. We didn't explicitly talk about it, but we have seen it in the lab. So one of the first things that we did was in this unit, we looked at a thermometer, and we looked at raising the temperature of water as well as alcohol. And when we increased the temperature, the volume increased. So all the particles started moving, and they were able to move through our glass tubing or our straw. Some of us saw it as a straw. So the process for finding values will look like this. On each of the problems below, we start with a given P, V, T, or N. We make a decision as to how a change will affect the others, and then multiply by the appropriate factor. So example 1, we have a sample of gas that occupies 175 milliliters at 35 degrees Celsius. We are asked to find the volume when the temperature is increased to 60 degrees Celsius. So our pressure and number of particles will remain constant. So the first step is to fill in the given P, V, T, or N values on the chart. Be sure to convert Celsius to Kelvin. That means we need to add 273, always. So our units always need to be changed over to Kelvin. We don't use Celsius. We put a question mark in the box of the value we are being asked to find. So we are given a temperature of 35 degrees and a temperature of 60 degrees. So 35 plus 273 gives us 308, and 60 plus 273 equals 333. So fill in the values. So our starting temperature is 308 Kelvin, and our starting volume is 175. Our ending temperature is 333, and we don't know what our ending volume is. Step 2 is to cross out any columns where the variable remains constant. So that's our pressure and our number of particles. So we have 308, 333, 175, and question mark. So determine how the change in the known variable would affect the change in the variable with the question mark. Indicate the change with a down arrow or an up arrow underneath the question mark. So we are not using pressure or number of particles. We have 308 beginning temperature. We have 333 ending. So 175 and question mark. So we see that our temperature goes up. So we need to determine what's going to happen with our volume. So if our temperature goes up, then our volume should go up. So we have our beginning and ending. Our beginning, we need to know our ending volume. If temperature goes up, then volume should go up. So think about how a thermometer works. An increase in temperature would result in an increase in volume. So now we're going to set up a T-chart starting with the original value associated with the question mark. So that would be 175. And this is milliliters. And then we're going to draw the T-chart. If the arrow points up, the higher of the two values, for the temperature in this case, goes on top, and the lower value goes on the bottom. If the arrow points down, then the lower of the two values goes on top and the higher value goes on the bottom. So the temperature, we want the higher temperature on top because we know that if temperature increases, the volume is going to increase. So we'll put the higher of the two on top. So we put the 333 on top and the 308 on the bottom. These were in Kelvin. So now we take 175, multiply it by 333, divide it by 308, and it gives us 189.2 milliliters. Example 2. What would be the new pressure if 100 cubic centimeters of gas at standard pressure is compressed to a volume of 75 cubic centimeters? So we have been asked to find the new pressure if we have 100 cubic centimeters, so that's a volume. So 100 cubic centimeters of gas at standard pressure. So STP, we read about briefly the other day, STP is 1 ATM or 760 millimeters of mercury, also 760 of torr, also 101.3 kPa, and 14.7 psi. So choose one of those. I quite often stick with ATMs. So standard pressure, that means it's at 1 ATM. So we're being asked what would be the new pressure. So we're looking for pressure. If 100 cubic centimeters of gas at standard pressure is compressed to a volume of 75 cubic centimeters. So we filled in what we know. We're not using temperature, we're not using number of particles. Our volume is going down, so that means that our pressure is inverse and our pressure needs to go up. So when we set this up, we put the arrow up, the higher number goes on top. So write down what we are starting with, 1 ATM. Do your T. Higher number goes on top, 100 cubic centimeters. 75 cubic centimeters goes on the bottom. So we have 1 times 100 divided by 75, which gives us 1.33 ATM. So now let's look at our answer. Our volume went down. We started with 1 ATM and it went up. So our relationship that we've observed the past few days is that when the volume increases, the pressure decreases. So it's always inverse. In this particular case, the volume went down, so that means that the pressure goes up. A weather balloon anchored to the ground is filled with 60.5 liters of helium gas at standard pressure and at a temperature of 25 degrees Celsius. The balloon is released. What will be the volume of the balloon when it rises to an altitude where the pressure is only 744 millimeters of mercury and the temperature is quite cooler at 20 degrees Celsius? And our number of particles is constant. So we are looking at volume, we're looking at temperature, and we are looking at pressure. So we have 3 things that we're working with this time, not just 2. So we're going to fill in the PVT or N values in the chart. Be sure to convert Celsius to Kelvin before you put it in the chart. So we have 25 degrees Celsius at 273. That gives us 298. So our starting temperature is 298 Kelvin. Our ending temperature, so we have 20 plus 273 gives us 293. So 293. So our temperature has dropped. We have a ending pressure of 744 millimeters of mercury. So standard pressure is 760 millimeters of mercury. So make sure you're using the correct constant, 760. We have 60.5 liters. We're being asked to find the volume. So this is what we want, is the volume. So we don't know what this is. Cross out any columns where the variable remains constant. So this gets crossed out. 760, 744 is final. 298, 293, 60.5, question mark. All right, step 3, determine how the change in the known variable would affect the change in the variable with the question mark. Indicate the change with a down arrow or up arrow underneath the question mark. So 760, 744, 298, 293, 60.5, question mark. So we're looking at volume and pressure. So our pressure went down. So our relationship between pressure and volume is that they're inverse. So we want a volume to go up. In relationship to temperature and volume, our temperature went down, so our volume should go down in that relationship. So when we look at pressure, we need to use the larger value on top because we're expecting our volume to go up. And with respects to temperature, we're expecting it to go down. So we start with 60.5. I'm going to work with my pressure first. So I'm expecting with the pressure that we need to put the larger number on top because I put pressure increase because we want an opposite relationship. 744. And then we'll set up our temperature. So temperature, we have a down arrow, so that means that we put the smaller on top. 293, 298. So pressure and volume have an inverse relationship. Our pressure went down, so that means we expect our volume to go up. So because we have an up arrow, that means we put the larger number over the smaller. With respect to temperature and volume, our temperature went down, so then we expect our volume to go down in that sense. So because we have a down arrow, that means we put the smaller value on the top of the T. So I have 60.5 times 760 divided by 744. Then I have 293 divided by 298. So 60.5 times 760 divided by 744 times 293 divided by 298. And that gives us 60.8 liters. That one is a little bit more challenging. We'll practice one more. Sam's bike tire contains 23 units of air particles and has a volume of 150 milliliters. Under these conditions, the pressure reads 12 psi. The tire develops a leak. Now it contains 13 units of air pressure and has contracted to a volume of 125 milliliters. What would the tire pressure be now? So we have number of particles, we have volume, we have pressure. So we don't have temperature. We have 23 units of air particles, so our 23 goes in the end column. We have a volume of 150 milliliters, and we have 12 psi. We now have 13 units of air, so our 13 goes under the end, and it's contracted to a volume of 125. What would the tire pressure be now? So we're looking for pressure. So we look at what our volume did. So volume, did it go up or go down? It went down. So what do we expect the pressure to do? We expect the pressure to have an inverse relationship, so we expect the pressure to go up. So that means when I set up the fraction with the volume, I have to put the larger number on top. Our number of particles, what did they do? They went down as well. In relationship to pressure, pressure and number of particles have a direct relationship, so we expect that if our number of particles goes down, our pressure goes down. So N has a down arrow. We write down what we're given, 12, make our T. We're going to do volume first. Volume says up arrow, so that means we put the larger on top, smaller on the bottom. N says down, so that means we put the smaller on top, larger on the bottom. So we have 12 times 150 divided by 125 times 13 divided by 23. Gives us 8.14 psi. So now you need to practice the deployment worksheet or the more PVTn problems. It will be due on Tuesday.